Human memory retrieves information through association. One thought links directly to the next. Early information architecture rested on a specific assumption. Because the human brain connects concepts associatively, digital systems should be built to do exactly the same. This vision of frictionless thought mapping drove the entire development of the systems we use to read on screens today. In 1945, engineer Vannevar Bush proposed a conceptual device called the Memex. It was designed specifically to let users create permanent, associative trails between different pieces of information. 20 years later, Ted Nelson attempted to construct a worldwide electronic network for sharing universal knowledge. He coined a term for this nonlinear associative linking, hypertext. This associative theory culminated in the creation and structure of the World Wide Web, built here by Tim Berners-Lee in the late 1980s. But cognitive psychology identifies a core paradox in this history. Building digital networks to mimic human associative memory does not actually make those networks easier for human brains to use. The theoretical promise of a seamless knowledge repository stands in direct contrast to the actual, measurable experience of modern digital reading. Empirical data proves that navigating hypertext imposes a significantly higher cognitive load on users than reading traditional linear text. In this environment, the brain struggles to process reading comprehension and spatial navigation at the exact same time. This dual processing requirement causes digital disorientation. Users quickly lose track of their original objective while attempting to move through the network. Navigating hypertext is a demanding cognitive activity that creates friction in the user's mind with every click. Nonlinear associative linking, the defining feature of the internet, operates as a systemic cognitive barrier rather than a frictionless conduit for learning. To understand why this friction occurs, we have to look at the structural constraints of the traditional printed volume, known formally as the codex. In a physical codex, the underlying information and its visual presentation are permanently fused together in a static, linear arrangement. Hypertext was designed as a deliberate architectural break from the physical constraints of the codex. The printed volume deconstructs, separating into a back-end database of text files connected by software links, isolated from the front-end display grid. Because of this split, the exact same back-end information can be displayed in completely different configurations without altering the source material. This separation of database and display acts as the invisible backbone of all modern online information systems. While this architectural split allows for dynamic publishing, it strips away the predictable, physical navigation cues that humans evolved to rely on when reading. A pivotal shift in user interface design occurred in the mid-1980s as graphical interfaces became popular. Prior to this shift, a database's navigational command menus and its reading content were visually and functionally separated on the screen. In 1986, researchers Larry Kovid and Ben Schneidman introduced the concept of the embedded menu, which we now universally refer to as the hyperlink. Look at the mechanics of the embedded link. Specific highlighted words within the reading text transform into 3D functional menu items. This design choice merged the consumption of content with the command of the system itself. The text itself became the primary interface mechanism. By merging the interface with the text, the reader is forced to execute a software interaction with every paragraph they encounter. While the general rules of language processing still apply to digital text, the screen introduces a new set of competing mental demands. On the left is text comprehension, the continuous process of parsing syntax. On the right is information search, a distinct process evaluating spatial paths. Forcing these competing engines to run concurrently causes a crash, creating a bottleneck in working memory. The reader must constantly evaluate whether to finish parsing a linear thought or to abandon it for a lateral navigational leap to a new page. This constant split-second triage between reading and steering imposes massive mental costs, breaking the utopian promise of frictionless association. The nonlinear structure of hypertext actively disrupts the process of unassisted reading comprehension. Digital users require a massive amount of external support to navigate these pages with a manageable mental cost. Effective systems must provide explicit hypertext organizers. As shown here, overlaying a clear visual content map snaps chaotic information nodes into a structured hierarchical grid. These organizers solve the bottleneck by separating the system's spatial map from the semantic text, relieving the user's working memory. Understanding the exact cognitive cost of the embedded link gives designers a rigorous framework for diagnosing why readers get lost on the web. Designing clear, explicit structural representations is a fundamental cognitive prerequisite for the usability of any modern digital system.